Hey guys, welcome to Unit 15, Lesson 2. Our topic today is U-Substitution with exponents and logs. So we are going to be doing in this lesson more indefinite integrals. Before we get into that part, I want you to be very comfortable with the derivatives. So for the warm-up, you have to find the derivatives of those two expressions. So let's start with part A. The derivative of E is just E. So it's going to be 1/5, the constant says e to the 5x squared plus 5x times the derivative of the exponent, which would be 10x plus 5, right? And the derivative of a constant is 0. So I can simplify that. I can factor out the 5 or divide by 5. So I'm left with e to the 5x squared plus 5x parentheses 2x plus 1. Or if I wanted to simplify that, I can also rewrite it as, if I was to distribute it, so, it would be 2x e to the 5x squared plus 5x plus e to the 5x squared plus 5x. So that's the answer for today's lesson. What I'm going to give you is the answer, and I'm going to be asking you to integrate that using U-sub. So let's look at another one of a derivative one before we get started with the integrals. So here again, the derivative we want to find of this expression, but I want to first rewrite it. I'm going to rewrite it as 12 ln of x to the 1/2 power minus 1. And now take the derivative of it, which would be, just use the power rule. So actually we'll end up using chain rule. So 12 times 1/2 is 6 ln of x, half minus 1 is -half, times the derivative of the inside, which is 1 over x, and the derivative of a constant is 0. So if I was to clean this up, it'll be 6 over square root of ln of x. So again, I'm going to give you that, and then we are going to work backwards to find the answer. Some tips and guidelines that you want to keep in mind when you are doing U-substitution. If something is being raised to an exponent, that will be your U. So I'm going to start, just underline those so that you can refer back. If one function is 1 degree higher than the other function, then that will be your U. So your higher degree function will be your U. And if you have an E, your exponent will be your U. And if you have a trig function, the inside of the trig function will be U. And if something is under the radical, that would be U. We can rewrite the radical as the exponent. So that would be something that we did in lesson 1. Also, one thing I want you to add, also something in the denominator. If you have something in the denominator, that will be a U. Okay, so let's get started with example 1. Example 1 is actually your warm-up part B, and basically the final answer to this would be 12 ln of x minus 1. So what do I do, or what do I pick my U to be to get that answer? So again, I'm going to, before I even do this question, I'm going to actually simplify it. I can rewrite it as 6 over x ln of x to the -half dx, right? So I can choose my U to be the inside of my parentheses, right? So U would be ln of x, let U be ln of x. So du would be 1 over x dx. But if you look at what I want and what I want to replace with, or what I have, what I want to replace with, look over here. I have, this would be my U, and I have 6x dx. But I only have 1x dx here. So what do? I'm going to multiply the whole thing, or the whole equation, by 6. So what I get, 6 du equals 1 over x, 6 over x dx, right? So I'm going to go and substitute in. So in place of 6 over x dx, I'm going to write 6 du, 6, and I'm going to write du here. Ln of x is your u, so it'll be u to the negative half power. And that's the integral of it, right? So the integral of u would be, I'm going to pull out the 6, it'll be u to the negative half plus 1 is a half over a half plus your c. Dividing by a half is same thing as multiplying by 2. So this would be 12 u, and 1/2 is just your square root plus c. I can replace back my u, which is what? 12 square root of ln of x plus c. So there you go. So we got our answer. And again, just deciding what your u is and then following along kind of makes it very straightforward. So here again, what are we going to pick our u to be? We talked about whenever we have e, we are going to be using our exponent and we're going to set it equal to as u. So u equals 5t squared plus 5t. And if you did recognize it, this is actually your warm-up question, part A, right? So now I'm going to take the derivative with respect to t here. So this is going to be 10t plus 5 dt. If you look here, I have 2t plus 1. So how can I make this 2t plus 1? Can I not factor out the 5? If I factor out the 5, I'm left with 5 times 2t plus 1 dt. So now if I go back to thinking, what do I have and what do I need to replace? I see that I have 2t plus 1 dt, which is there, right? So I'm going to do is divide by 5 because that's what I need. So I'm going to divide by 5. So du over 5 is equal to 2t plus 1 dt. So in the question, I'm going to replace that with d over 5, and it'll be e to the u, right, times d over 5. I can pull out the 1/5 du. This is the easiest integral you can get. The integral of e to the u is just e to the u. So 1/5 e to the u plus c. Your u happens to be 5t squared. So this is going to be 1/5 e to the 5t squared plus 5t, right, plus c. And that's what we got. So let's do a few more here. Actually, it's telling us what our u is. So that's pretty straightforward. And let's see also, is that the u you would have picked? So again, you want to pick something in the denominator and if it's inside the parentheses. So that is definitely -1 plus ln of 4x is inside the parentheses. So I'm going to do du. So the derivative of u with respect to x is, the derivative of -1 is 0. The derivative of ln of 4x is 1 over 4x times the derivative of the inside, which is 4, and it'll be dx, right? So the 4's actually cancel out, so I'm left with du is 1 over x dx. So now I can actually clean this up a little before I even go further. I'm going to change colors. I'm going to pull out the 2, and let's see, what do I have? 1 over x, -1 plus ln of 4x dx. So I do have dx over x, and the inside would be just u. So 1 over x dx is what? Du. So my integral is going to be du over u. Or I can say it as 1 over u, which is same thing as rewriting as 1 over u du. So we want to think about whose derivative is 1 over u. It is ln of u, so it's going to be 2 times ln of absolute value of u plus c. Substitute your u back, ln of -1 plus ln of 4x plus c. That is your answer. Let's do one more. Here again, my u is already picked for me, so I am going to actually find my du. So du would be, again, u is your exponent of e, which we kind of talked about. That's what you want to pick. So this would be 12x squared. Derivative of 3 is 0 dx. I need, now again, check what do you have and what do you want to replace with. So I have 36x squared here and I have 12x squared here. So I want 36 instead of 12. So what would I do? I would multiply this whole thing by 3. So I have 3 du equals 36x squared dx. And okay, I'm going to replace this part with 3 du, and I'm going to replace this part with u. So I'm going to pull up the 3, and I have e to the u du. Again, e is a very straightforward integral. So the integral of e to the u is just e to the u plus c. So plug back your u in. It is 4x cubed plus 3 plus c. Let's do number 3 also. So here you actually had to decide what you want to pick. So as we said in the past, we are going to be picking if there's an e, you pick the exponent to be used. So I am going to say let u equals 1 over x. So du is going to be, this can be rewritten as x to the negative 1, negative 1 x to the negative 2 dx. Yes, which can be simplified. If I make my exponent positive, it will be negative 1 over x squared dx. So again, look back at the question, what you have and what you want to replace with. I want to replace 1 over x squared dx. This is negative 1 over x squared dx. So can I divide both sides by negative 1? So it will be negative du equals 1 over x squared dx. So let's replace this, e to the u, and times, this would be what? Negative du. Or can I put the negative out? And that would be it. This becomes a very straightforward integral, which is just e to the u plus c. Your u happens to be e to the 1x plus c. I'll set up the last one too, but it's pretty straightforward. You see another e in there, so you're going to pick your u to be negative 3 plus ln of 3x. Finish that up, guys, and finish the lesson. If you have any questions, please do not hesitate to reach out. Good luck, guys.